All right, so now plug in your initial condition. So v at 0, this is v at t. If we're saying v at 0 is 0, 1, -1, you kind of can break this up into a bunch of different equations, but you could say 0 plus c1, 2 times 0 plus c2, and then c3 plus 0 is c3. So if it helps, you might want to write like each component and an equation for each component. So you have 0 is equal to c1. 1 is equal to c2. -1 is equal to c3. This case didn't really need separate equations to solve it, but now we're going to plug that back in. So take those initial conditions and sub it back into the velocity. So we're going to have t plus 0, 2t plus 1, and then 0 plus -1. Okay, try to find the position. Use that initial condition. Okay, how do we do? Mucho bueno. I think that we kind of get it, but you can try to do number 4, but we're moving on to components of acceleration. So the components, the things that comprise an acceleration vector. Acceleration is made up of AT, that's like a subscript, times the unit tangent we found last class, plus AN times the normal vector, normal unit vector. We have to multiply the components by these unit vectors, T and N, because they help us find the direction. These are really directional. So then how do we get AT? A sub t is the velocity, the derivative of the velocity. So it's going to be r prime dot product r double prime of t. It's like the velocity, I guess I should say, over the magnitude of r prime. What formula, what thing does this look like it's doing? Not the unit tangent vector. The unit tangent vector is r prime over the magnitude of r. This is the dot product between two vectors over the magnitude of one of them. Yes, it's a scalar projection. So this is going to be a number, typically. Although, no, because r is going to not be the dot product. You're multiplying actual, like, variable times variable. So probably not going to be a number, but it's not going to be a vector. That's what I meant to say. This is not going to be a vector. So this is going to give you a scalar or some non-vector thing. So it should not be. This is not a vector. So this component of the tangent is parallel to our acceleration. I mean, I said tangent. This component of acceleration is parallel to the acceleration. It is going in the direction, and then the unit tangent helps us actually extend it and get it actually moving with the acceleration. But you need the other component, the orthogonal component or the normal component, to fully comprise the two of them. Did we not finish writing this? I don't know if you did or not. So our normal for acceleration, normal component, is kind of like the curvature times the velocity squared. So that's K for curvature, or kappa really. And just remember, curvature is equal to the magnitude of r prime cross r double prime over the magnitude of r prime cubed. And then if we're multiplying it by our velocity squared, we'd be multiplying by r prime squared. And what happens in the denominator and numerator? You see how they're going to cancel out, and that's why it's like looking kind of like the curvature equation but not cubed, is because of multiplying by the velocity squared. Okay, and this to me is we're thinking about the fact that it's a cross product. What does a cross product give us again? An orthogonal vector. So the normal tangent, normal component, I mean, is also going to give us that orthogonal vector in the direction of our acceleration. So this is like perpendicular to the acceleration. Okay, finding the tangent and normal components for acceleration. Hopefully I have enough room to write all of this on here. How big is this page? Oh, we should be okay. Okay, so we're going to need to find r and r double prime for both of these. That's where I would start. I want to add something to this, though. We're saying the scalar projection, this is in the direction of the motion. And then the normal acceleration component is orthogonal to the direction. So it's like the thing pulling the thing gets moving in towards the center of the curve. Okay, so r prime, 3 minus 3t squared, and then 6t, and I'm going to make sure I have 0 in there as well, because eventually I'm going to have to do the cross product between these things, so I want to make sure I'm thinking in 3D. Okay, AT is the dot product between those over the magnitude of r prime. Oh, maybe we should find the magnitude of r prime while we're here. Magnitude r prime. Nine minus 18t squared plus 9t to the fourth plus 36t squared plus 0. Nine t to the fourth. Okay, so we have 36t squared minus 18t squared is positive 18t squared plus 9. And so that you see, a lot of the time these, a really well-written question is gonna go from having something with a minus sign, and see how it's like, gave us minus 18t squared, and now when we simplified things, it becomes plus 18t squared, so your factoring can be a little bit easier if you notice that. Or you could take out the 9 and factor. Let's say right the other way around. And square root both of those, we get 3 times t squared plus 1. That's what's all the denominator is going to be. Okay, so dot producting. Three minus 3t 6t 0 dot product. Okay, so this is why we had to do chapter 13 first, because we need to know how to do the dot product, and we need to know how to do the cross product, and we need to know how to do the magnitude. So here we go. Dot product. We're multiplying the I components together, the J components together, plus, and then plus K get multiplied. So we got negative 6t times, maybe just think of distributing it, times the 3 minus 3t squared would be negative 18t plus 18t cubed. And then we're going to have 36t and 0 over, oops, plus, hello, plus. Okay, combine like terms. What's the greatest common factor in the numerator? 18t. I'm left with t squared plus 1 over 3t squared plus 1. Just want you to imagine for a second that the highest level of math you ever got to was algebra 2, and you never understood why you cared about factoring so hard unless you kept going through math. What a shame. Okay, so we get to 6t. This is our tangential acceleration component. I have to think of the other words. I have to say it slow. Now let's get our normal acceleration component. So we need the cross product between these. So first let's do, instead of AN, let's actually do the cross product between R prime and R double prime. This is, I think, the most laborious part of this entire thing is the cross product. Kind of anytime the cross product comes up, it's when things, it's just like a place where you could make a lot of mistakes. So maybe it's just I don't like it because I have to grade and try to figure out what mistake you made to give you whatever follow-through questions I can try to find for you. That's a t squared. My left hand is kind of making me struggle today. Okay, so we got a 0, a 0. This is our only thing that is actually giving us any information. And then we got that's our only thing. The other ones are all going to be 0. Negative 36t squared, and then it's subtracting, so it becomes a plus. What do you think the magnitude of this is going to be? The same thing, but without the k. Right? Because you're taking the magnitude of 0 squared plus 0 squared plus 18 plus 18t squared squared. So really the only thing that is like doing anything is that k component. And it's all of that being squared and then square rooted, so they cancel each other out, and you're left with 18 plus 18t squared. I think we're going to have to come up here. So an is that quantity over 3t squared plus 1. And so that should simplify. Factor out the 18. We get 6. Wow. That was so much work. Okay. I want you guys to do this one on the board. Grade your quizzes. Done? You want to pass it? Oh, you can do it. Let's go. You got 7 minutes.
this turn on for you?
No, it's okay.
Oh, that's the.
Elizabeth, will you just put it on like my keyboard?
Why do you so much fun?
Okay, so it says 4, No, not 2. And there was no K anymore, just 2.
Oh, yeah.
You put 8 and
It's actually not even just chicken, they lied. It's,
Oh,
wait, never mind. But yeah, it's seasoning, yeast, garlic powder.
you barely did anything. Barely did.
Did you see Djokovic did the K-pop? Ben, that's so funny because literally when I wrote the answer was DME, I also thought, oh, look at Miss Ray giving some hints to the answer to my quiz. I should make sure I tell her that. She'll think it was so hilarious. Like, oh my gosh, look, I know math. I'm a math genius. Okay. It's a little horrifying. Oh, I need to give you back all of your quizzes. Do you want to know if you're right or not? Let's see. Did we get... I did not factor the bottom at all. My magnitude I got was... So AT I got 4t minus 4 over square root of 4t squared minus 8t plus 5. Does that factor?
I don't think so.
Okay. Oh, I'm looking at, I think that was, wait, what did you guys do over there? I don't know. Oh, you did the curvature. Oh, that's old. Okay. That's what, I'm like looking at like 2 days ago work. And then this one should have been, did we get these? Yeah. Woo, yippee. Okay, let me write down your quiz scores before I give them back. All right, we have homework. We also need to be finishing this weekend.
It's all it ever was. That's the fun thing. So 3 hours we have never actually done. This is all good algebra.
Wait, do they divide before?
Let's check. He was at 0 all of them.
What is it? Is he getting crushed?